So thanks for the opportunity and the introductions. I'm here to talk a little bit about a new platform that we're working on in collaboration with Intel. So Red Hat and Intel are working together to build a much more robust platform, to build a much more open, sort of aligning with what Harry was talking about in that IT/OT convergence area, to provide a platform that's able to do a lot of the things that he just talked through. And I want to be clear, and I'm going to make that clear on this slide. We are not building a new control system. We're not building an entire new architecture. We're building the platform of which control automation, of which AI, of which all of the new industrial platforms that all those new containerized workloads can actually run on. And a lot of the basis for the stuff that Harry talked about is really driven through, he sort of mentioned open standards and where open standards are driven. So things like Industry 4.0, Nomura, Open Process Automation Group from the US will talk very heavily about a lot of these open standards, about how that IT/OT convergence can really optimize and make industrial automation much cleaner. So what's really behind a lot of this drive? What's really pushing this IT/OT convergence? When you look at a lot of the challenges today that industrial automation systems have had for many, many years, there's a lot of challenges around interoperability, for example. So, integration of a best-in-breed system, if you're picking pieces, parts because of their superior technology and trying to integrate those together in today's ecosystem, in today's industrial automation ecosystem, it's very complicated to do that. A lot of the energy, a lot of the money is spent in just completing that integration work to make those things work together. There's almost always custom code that gets created to make that integration happen, and things just aren't really plug and play when they come from multiple vendors. A lot of the products are fixed functions, so they do one thing, and they do one thing very well, but they really do one thing, and the workloads that are really tied very heavily to the hardware. So it's very difficult to replace a piece of hardware or something from a specific vendor with another, because that connection of that workload is very tied to the hardware. Upgrading a system is challenging. Being able to adopt a new technology that say a new historian comes out with a new compression algorithm that you want to adopt very quickly. A lot of times doing those kinds of upgrades require large system upgrades and large system upscales. And that gets very expensive to adopt that new technology. Software upgrades are more frequent nowadays since people are connected all the time, much higher level connections to things to do reporting and higher level systems into the cloud. All of those patching requires a lot more system updates, and those system updates can be awkward and difficult to manage in today's infrastructure. This next one, this heavy pressure on productivity. Everybody on all of these plants in the world are getting asked to do more with less. It's a very competitive world out there nowadays. So all of that competition from a global ecosystem makes it much more difficult to remain profitable as a company when you have so much competition. So how do you stay profitable? How do you stay competitive? Certainly, you can add resources, you can add people, you can add capacity at your plants, but those are very expensive additions to grow and to stay competitive. Things like AI, things like predictive downtime, things like that we found are much more prevalent in the market now, and they're becoming much more intense to be able to get more productivity out of the existing ecosystem. And lastly, the learning curve on the legacy systems is very high. You'll see a lot of people coming out of college, and those skill sets to keep those legacy systems, to keep those controllers, that workloads working, is not necessarily taught in college, it's learned on the job. So having older technologies, those existing technologies out there, is just something people don't know out of college. So a lot of times you have to learn that on the job, and it's harder and harder to find people to do that kind of work now. Next slide is sort of an example of a real world scenario of what was originally a very simple, very inexpensive, relatively inexpensive upgrade to a system to patch a controller, to patch a vulnerability. And what ends up happening in closed systems and proprietary systems where there aren't well-defined interfaces and well-defined standards and plug-and-play capabilities is it tends to cascade a lot into higher, more and more expensive as you move through the system. So upgrading those controllers in that architecture turned into adding, patches to upgrades on the database. It ended up HMI patches to get things like trends to start working properly again. Ended up having to re-roll a bunch of historian content, and all of the patching code that was made and custom built to make all that stuff work together originally had to be done. And the real takeaway from this slide isn't so much all those individual pain points, but picture yourself as the control engineer or the control manager, going to your management and telling your management, we have to spend about $30 million to upgrade all of these control systems, and there's no productivity improvement. There's no production increase. It's just to keep the system stable, to keep the system running, and to keep the system current. That's a very hard sell, and a lot of times that gets neglected. That tends to make systems stay in place for 20 years and don't get upgrades. So that's some of the challenges that the existing systems have today.
Thank you, David.
Sure.
And thank you, ARC, for allowing me to be here as well to chat a little bit through kind of what we're going through. So David has set the stage on some of the challenges that are in place. And if you take a step back and look at this from, where are we and how's this transitioning happening? There's probably three phases at a high level that you see. So sense, think, and act. At the beginning of this transition, we started talking about how to just connect the unconnected. How do you start getting data out of machines that never had provided data in the past and releasing that dark data? So now we start to see the visualization of those assets, and companies and manufacturers want to know, well, what do I do with it? So now we move into sort of this middle box that you see on my screen of analytics. So a lot of activity happening here today in this space: anomaly detection, product quality optimization, even factory productivity and worker safety through visual and vision capabilities. You're starting to see digital twin, maybe offline, the advent of IA in manufacturing, as it evolves from machine learning. And you are starting to see, as we create more of an IT type of system in the factories, that you're able to understand and move forward a little bit more with what you've got. And then as that manifests itself, now you've got a lot of data and you understand your factory and you see what's happening in real time. You want to know, what do you do with that functionality? And you move more into this act. So as you start moving to the box on the right-hand side, you're working towards an autonomous factory. So you're starting to get recommendations on low latency. You're closing the deterministic control loop. And the idea is that the factory is learning and adapting. So it's becoming more self-sufficient, if you will, in order to keep it stable, make improvements, heal itself, if you will, and kind of move into that space. So if you look at this continuum and you say, well, where are we in this phase? It's more in the middle of the box, right? So right now, we've seen a lot more connections happening, a lot more devices being placed that are being connected. And as evidenced here by the number of bullets in the middle box, I guess is probably an indicator too. All of these activities are happening post haste right now in order to, move towards that next level of productivity, the next level of quality. We saw an acceleration of this actually during the pandemic somewhat, because some of these activities had to be implemented in order to be able to make that kind of thing happen. So we're in sort of the think stage of the transition right now. You're starting to see some localized, virtualized control, maybe not a whole factory, certainly some POCs and field trials in that space. But the overall market is moving in this overall direction. So if we could move to the next slide, David. And so how does this sort of manifest itself? So I think you've heard this message a little bit from Harry and David, where you're starting with the Purdue model and Industrial 3.0, if you will, and we've got the functional layers that have been that way for quite some time. But as we move forward into the convergence of IT, OT, and even AI, all of those layers start to blur. So you still go all the way down to the device layer and the sensor layer, and you're connecting all of that information and all of that data both at a local level. So think machine control, and you're moving general compute into that space so that the machines themselves can be smarter. But now you want to start acting in a broader way so that you have to connect that up to the cell level, to the line level, to the factory level. And so as you move up that stack, you create this connectivity need to deliver data and functionality across that entire continuum. So you've got both compute functionality from all the way from the device to the cloud, but you've got to do that in a way where you virtualize and containerized the control functionality, the data functionality, and you've got to be able to do that in a deterministic networked way and have a low latency network. So this is happening. This shift in backbone is happening across both manufacturing and utilities. And so there's several companies. This is not meant to be exhaustive or complete or anything, but we're seeing it happen in manufacturing as Open Process Automation Forum has been mentioned several times. Probably one of the early standards bodies trying to work through this OPCUA towards a TSN functionality. And we've seen the utilities accelerating here as of late too with the VPAC Alliance and E4S in order to be able to virtualize their networks and the grid, because one of their expensive pieces of maintenance for them is if something does go down or shift, they've got to send a truck out. So this allows them to be able to handle some of that remotely from their control rooms. So one next slide for me, David, please. So what does Intel bring into this party? So obviously you all know us from our silicon, and we continue to do that. We're building industrial silicon from all the way from the edge to the cloud, specifically also bringing in software pieces to enable the functionality of that silicon and working with partners such as David from Red Hat is here with me today. And, for machine builders, for discrete automation, even specifically for robotics and then process automation as well. So in order to do these functionalities, there's a couple key features in our silicon that have been baked in. One is something called Intel Time Coordinated Compute, which allows clocks to be synced across all the devices in the factory that are running with that silicon. And then time-sensitive networking, which connects all these things together and allows that to happen. And so we've utilized various features, the hypervisor, the firmware, secure device onboarding, cache locking, among some other things. And you can learn more about that in the lower left-hand edge of this slide. There is a website you can certainly go to understand sort of those functions and features that are built into the Intel silicon specifically for industrial. And so that long life, the connectivity that's necessary. So we continue to work with end users, partners, software suppliers, hardware suppliers to be able to work towards this workload consolidation, this blurring of the Purdue model, and delivering virtualized capability into the factory. So thank you. Back to you, David.
Yeah, so let's talk a little bit about some of that new system mentality. So you mentioned the Purdue model, and this is a great picture of the Purdue model. I know Harry talked about it a little bit as well. But if you look at the layer 4 or 5, those are the enterprise layers, the cloud layers, and that's part of this industrial architecture as well. What we've created here is a platform that can run throughout the entire stack of the Purdue model. So layers 4 and 5 were traditional IT layers. And a lot of the stuff we talked about, those challenges we had earlier on, the IT departments have already solved a lot of that. And that's really what's driving a lot of this IT/OT convergence, because a lot of those challenges from those IT departments or from those industrial automation layers have been solved by IT departments already. So things like container management and managing workloads and delivering those workloads in a easy, manageable fashion as well as managing and patching and upgrading and taking out all of those manual tasks that you typically do. That's already been solved to a large extent in the enterprises and the cloud layers and in those higher level 4 and 5 systems, but not so much on the layer 3, layer 2, down to those control layers. And that's where we're really starting to see a lot of these tools that are traditional tools in the IT space slowly migrating their way down into that lower level. So that's what Harry was mentioning, containerized control being a thing that's starting to come out a lot more. And so having a containerized control system and being able to manage that all that containerized control, if you've got individual workloads that you need to distribute. And it's not just control, by the way. So a lot of the HMIs, the SCADA, the historian packages, all of those are legacy packages, and many of them are built on Windows. So what we're seeing as we move forward, a lot of those IT technologies are containerizing even those workloads and spreading those throughout the infrastructure. Interestingly enough, as you get more horsepower moving down the stack, that's really driving a lot of this content moving down. So a lot of those layer 3 workloads that were, running on a server that sat on the plant floor are migrating down into smaller and smaller devices, smaller and smaller elements, which makes it much more compatible to have a smaller, lighter weight operating system. So the platform that we're talking about that we've worked with Intel to create here, will run throughout the entire stack. And carry those workloads and manage those workloads and patch those workloads using standard open IT technologies. So when you talk about that platform and what it really brings to the table, it really adds and solves a lot of those challenges we talked about in the past. So interoperability, plug and play is now a much more possible thing with these containerized workloads, and having a much better defined API, better defined standards-based solutions instead of proprietary content. Having hardware that's interchangeable means those workloads are portable from pieces of hardware to hardware. So you don't have that lock in on a software container or on a workload from industrial automation locked to a specific, PLC brand or DCS brand. Easier to upgrade, easier to patch, downtime gets reduced because now those connections to AI, connections to predictive maintenance, all of that becomes much simpler, much more standardized. Productivity increases because those AIs can do things with all of the new data that's now been exposed because of the standard interfaces, can do more things to optimize loops, and do that predictive stuff. As well as, the skill sets of people coming out of college, of the younger group, have a lot of the skill sets to manage a lot of these IT tools already in their tool belt. So you'll have much better workload or much better workforce, more educated for this content. If you look at the platform and what we're really talking about here in this architecture, the advanced compute platform is the places where, Red Hat and Intel have always notoriously played. It's that space where you have either on-prem server, cloud server, your own data center, or an enterprise layer content. And obviously we have a large footprint there already, and that's where we traditionally play. But you'll see these containerized workloads working down that stack into PLCs, into controllers, into industrial computers that live down on those floors, or other devices as you move even farther down the stack, managing IO adapters or running, managing and patching firmware on IO adapters in the realm of possibility here. So this is where we're headed, moving lower and lower down that stack with a platform that's scalable to move throughout all of that ecosystem. So to wrap this up, and Darren, feel free to chime in on any of this, the takeaways we want to have here, obviously, additional compute power, moving down that stack provides flexibility and opens the door up for hardware container or for software containerization and workload containerization. I don't want to say commoditizes the hardware, but it makes the hardware easier to replace, easier to swap in and out of, because the portability of the containerized applications can move between the hardware. And it's really about a true IT-OT integration. So 5 or 10 years ago, we'd talk to you as an industrial automation guy, we'd talk about IT-OT integration, and we were really talking about network interfaces, about network, having Ethernet on the plant floor. Now we're talking much more about those containerized workloads, about management layer software packages, moving down into that stack. So it's a next step of that movement. And I think a lot of that is driven by this collaboration. And I know, Darren, you want to talk about some of that
Yeah,
particular.
I think, and to just to reemphasize David's points here, as we put general purpose compute across the network and we bring some of the key IT technologies with the critical functionality of OT, what it allows us to do in that sort of opening up of that stack is create this collaborative ecosystem. So one single technology won't deliver everything in the future. You'll be able to pick and choose and move and upgrade and have portability because of that collaborative ecosystem. So you can look at, there are many layers or many pieces of technology available. And one of the things, I think I was at one of the original OPAF meeting that came out was, we want to be able to open the door for innovation that can come from anywhere. And that's been a challenge in the past. And so opening this up to multiple vendors that are collaborating um, actually allows that to happen. So not only this is good for probably the pace of innovation that will happen in this space in the future.
Okay, thanks very much.